Okay, the definition of torque we've seen is tau, Greek letter tau, equals the magnitude of the force times the magnitude of its position times the sine of the angle between those two things. Now, we do not write the absolute values, and instead we just write the equation as force times distance or position times sine of theta. The Greek letter tau, it's like a regular t, but then you kind of curl this down and you curl this over. Okay? There are 4 things that we need, not 3, so perhaps maybe you add a line at the bottom, or you could extend this across. We have the torque itself, the torque from a force, F. We have F, the force which is applied to object. We have next R. R is the distance, or position, I'll call it distance, from where the force is applied to the pivot axis. And you might be thinking, isn't it a pivot point, not a pivot axis? Well, consider like a sphere. And the sphere is allowed to rotate around this way. So there's some axis of rotation. The same is true for a wrench. If you get a wrench, and this is kind of a 3D picture, you tighten around a bolt, and you're going to let it rotate around this way. Well, there's some axis of rotation. So the rotation, the pivot axis, is better described as an axis than a single point. Finally, we have theta, the angle between the force vector and the position or distance vector. Probably position would be better because distance is not a vector. By the way, the thing I'm not mentioning is that really it's the magnitude of the force, the magnitude of R. So that's something to remember. The force then, since its magnitude can only be positive, R we're only going to let be positive, theta will only be positive, but torque can, surprisingly, be positive or negative. So we're going to talk about that. Force is measured in newtons. R, distance, is measured in meters. We'll use degrees for theta. So if you're plugging in a newton here, a meter there, well, when you take the sign of degrees, you don't get any units, it's just 1. So we have Newton meters as our unit for torque. Newton meters is the unit of torque. Torque is a vector. It can be positive or negative, and that positive and negative sign shows you the direction. But the directions we're going to use a little different, slightly different directions. If the object is rotating clockwise, we're going to make that negative, clockwise is negative, and counterclockwise or anti-clockwise, as it's called, is positive. This is negative. We can add up torques to get the net. Torque 1 plus torque 2. Each one we have to make positive or negative. Now, we want to understand how this is different from work, because work, you might recall, is the magnitude of the force times the magnitude of the displacement times the cosine of the angle. So it's very, very similar. In fact, isn't the unit for work Newton times meter, and we call that a joule? Well, why aren't we calling it a joule up here? Shouldn't I have written down a joule? The answer is no, we don't write it as a joule. We actually leave it as a Newton meter because we don't want to confuse that for any unit of work. We're saying torque and work are very, very different things. Even though they might technically have the same unit, we are going to call the unit Newton meter for torque and joules for work. So it can get a little tricky, but there are differences. I mean, compare the two equations, right? just look at the two equations. They both use magnitude of the force. Well, there's a difference there already. There are two main differences just between the equations themselves. Write down those differences. But then there's another difference. So write down those two. And what's the other difference? Is work a vector or scalar? When we do torque problems, right, we use force times distance times the sine of the angle. We add that positive or negative in ourselves to depending on whether the thing would rotate clockwise or counterclockwise. Okay, here's the first one. The pivot axis is coming out of the page. So it's like going down into the page and out of the page, so the thing is either going to swing this way or this way. And we can really drive that point home because if I take my bar, it's going to swing down to here next and then down to here, right? The pivot point does not move. So it can either swing down or it can swing up to here and then up to here. It can either swing down or swing up, clockwise or counterclockwise. But this point is always fixed. That's why it's the pivot. Well, that's what we mean by the pivot axis. Okay. You imagine this force. I actually like to take my pencil, and I put my pencil on my paper. Here's the pencil. And I take my finger, and I hold my pencil right here at the pivot axis, and then I push with my finger in the direction of the force. And my pencil would swing around this way, which is clockwise. So when I do the torque equation, I'm going to do negative force times distance times sine theta. Let me leave a spot for theta. What's the force? 15 newtons. What's the distance? Oh, centimeters. 0.44 meters. The angle is 35 degrees. That's the angle from the force to, well, it's not the angle. The angle from the force to the distance is this. This is the distance. Here's the force. And that's 180 minus 35. That's going to be 45. But if you want to see something cool, type sine of 145 into your calculator. And then type sine of 35 into the calculator. It's the same value. If we think about the unit circle, if you work up some angle here, and then you go up the same amount there from 180, they're going to have the exact same y-coordinate. So the sine is going to be the same if you're working, if you're going up 35 from 0 or up subtracting 35 from 180. The sine of the value will be the same for both. So it doesn't actually matter if you do, you could do sine of 145 if you want. It'll give you the same answer as if you use this angle. Like you imagine extending out r, extend r all the way out, and then mark the angle with the force. That's another way to mark the angle theta. When we put this into the calculator, what do we get? Okay, because I'm using this thing, I have to do sine first. Then I'm going to multiply by 0.44. And I multiply by 15. I can't forget the negative. It's negative 3.8. And what's my unit? Oh yeah, newtons times meters. And I leave it as a newton meter. I do not change it into a joule because that's what we do only in the case of work values. So this is how we solve.